So today's a little bit different style of lecture. If you download the slides, you'll notice that I really don't have slides for this one. We're going to go through an example of a chat app. We're going through essentially the functionality of the chat app from 1.15, but we're going to use WebSockets to build that same app. We're going to have a desktop version and a web version, so we can see a lot of the pieces minus the actor system, but a lot of the pieces of the MMO architecture, what we're using for lab, what we use for the last homework, and what we've been showing off and learning about in lecture. And then next week we'll add actors, not to a chat app, we'll use a different app for next week, the 2 lectures, and see how it works for the full architecture that we're using for this class, for our apps. So we'll see a chat app, typical chat app, one room, you send a message, that message goes to all users with your username attached to your message. So basic chat app, we're all familiar with that. For your lecture question, a variation of this, but build a DM server. So sending direct messages to a particular user. So think about this as we're going through the chat app, how would you modify this to be able to be a DM server where users can register their username, which we'll see in the chat app, that part's the same. But then a user, instead of sending a message to the whole chat, they'll send a message of type direct message with a JSON string of who this message is to, and then the text of that message. So all the users register their username, and then they can say, send this message directly to this user, and then the server should send a message only to that user. So, and also say who it's from. So the user will get, okay, I got a DM from this user with this message. So this is going to require maintaining those socket references and attaching them to the username of each user. So we need data structures, and we'll see this in the chat app. We don't really use them for the chat app, but I wanted to set them up to show you how it works for this, because you have to do something similar for the clicker assignment too. That we need to, every time a user registers, we need to affiliate that socket with that username and have some data structures to link those references together.
Do we need any database?
Not for the lecture question, but we'll see a database for the chat app, but you won't need one for the lecture question. Lecture question grading won't look for a database. So the whole class is going to be just going through the demo. My next slide is right back to the lecture question. It's the last slide. So let's hang out in IntelliJ today. And since this is a different style, I'm going through the code and just explaining everything. More so than most lectures, feel free to interrupt me with questions. I'll be at least attempting, this mic. I'll at least be attempting to watch the Twitch chat and the Discord during lecture to get questions from there as well. So let's see if we didn't expect a Hail Mary mail-in reference. Never know what to expect in 116. All right, so let's take a look at this app and jump in to this to get started. So first, let me find my magnifying glass and show the package that we have. So I have all the files for this app in the same package, in this chat package. It's in the examples repo, so if you want to pull the repo and follow along, it's in the week 8.chat package that has all the files that we're looking at here, and they're all up to date. I just pushed right before lecture, so it's all the most up-to-date files with all my latest changes of this app. So we have a few files. We have the server itself, where we're going to start looking at these things, a chat message class that we're going to use to store messages, which just have a username and the message of that message, the text of that message. And in that class, I actually use a little bit different syntax that I'll talk about. I'm going to sprinkle in a few new Scala features today as we get into the language more. I'm going to start, like I said earlier, I'm going to start showing more features of the language. And then the database, which is going to connect to the MySQL database. I'll remind you again as we get to that file, but for lab next week, you will have to have MySQL running on your machine. You have to connect to a MySQL database and do something with that. The lab itself won't be overly complex. It'll be fairly straightforward SQL statements, as long as you have MySQL installed, running, and tested before you show up to lab. So I gave you Warning, last week on Friday, giving you warning again today, if anybody shows up to that lab without MySQL downloaded, installed, and everything, you're just going to be SOL. You can try to do the whole lab, download, install, run, test, and do the lab in 2 hours, but it's going to be difficult. So make sure you do that before lab. All right, so let's start looking at this, and let's start with the server. Turn my magnifying glass off, zoom in. Can't really read this sidebar anyway, so let's hide this a little bit. Collapse some of these packages. Let's just go through this pretty much line by line. The first part, we've seen this before. Setting up the server, I want to listen on localhost port 8080. I'm going to listen for connections, WebSocket connections on port 8080, and I want to start my server to start actually listening, to fire it up, start listening on that port for socket connections from all the clients. Then I want to add my listeners. So on each event or message, I want to do something. So I have to have these classes, these listeners, that are going to extend the appropriate listener. Registered listener is listening for strings. Chat message listener is listening for strings. And disconnect listener, not listening for any information in particular, but just listening for that disconnect event when a user disconnects. Now notice I'm not using the connect listener. I just didn't have any functionality that I wanted to use when a user connects. Instead, I'm using the register listener, so I don't really care when somebody connects and opens up a socket connection, but I do care when they finally send me their username. So just a socket with no username, I'm not going to be concerned with that. We're not going to allow people to just sit in on the chat without registering a username. So I'm going to listen for that username and then start working with that user. Similar to the clicker, we don't care when somebody initializes a socket, connects a socket to our clicker server, but we do care when they send us the username with the register message and say, hey, I am this person, let me start a game. And of course, in between there would be, for a full app out there on the web, would have our authentication. They would have to log in with their username and password. Then once they log in, the register message would be sent with their username, and then we'd initialize everything for them after they authenticate. So we're kind of simulating that, but we're skipping the authentication. We did that in 1.15. We can add that to our apps. Maybe we will by the end of the semester in at least one example. But that's where that would go. And then after they authenticate, the register listener would get that registration message. So with register and disconnect, we don't want them to send a special message when they disconnect, when they stop using the game. We just want to listen for when did the socket close. Because if a user just closes the tab of this game or just closes the GUI, this disconnect message is going to be sent when they do that, when they actually disconnect. So we want to listen for that disconnect. We don't want to require the user to do something specific, or else if they skip that step, they're always going to be in our app and treated as an active user even long after they're gone. So we listen for disconnect, so we always make sure they're disconnected properly. So with these two, there's only one real thing that I'm doing with these two, these register and disconnect. I'm keeping track of the users who are currently using the app. And I'm doing that with two different data structures. This could be done with one, but I don't know. For my preference, I like splitting these into two. It's duplicate data, sure. But I find it just easier to work with. If you're really concerned about memory, you would squash these into one database, one data structure. But I like having it in two. You can do whatever style fits you best. But I want one data structure, so if I have somebody's username, I want to be able to look up their socket really easily. And if I have somebody's socket, I want to be able to look up their username really quickly. So these two data structures are going to let me do that. I'm going to go from username to socket and socket to username. So no matter what, if I have one piece of information for a user, I can always look up the other one with just one map lookup. Just one key access, give me the value at this key. Constant time lookup, we don't really talk about asymptotics in this course yet, but it's all constant time operations. Just give me the value at this key. Very fast operations. Requires duplicate data, but I like the efficiency of the lookups and the ease of programming the lookups. But any way you do it, you need some data structures to be able to link this username with the socket. For the clicker homework, you'll be creating an actor for each connection. So when somebody registers, instead of just linking their username with that socket, you'll want to create a game actor in the system for that user, get the actor ref, and then connect that actor ref to the socket, and the socket to the actor ref. So similar concept, but instead of strings here, you would have the actor ref. So if this actor sends me a message, which socket do I need to send that message to? Or if I get a message on this socket, the user enters an input, what actor do I send that message to? You'll need those two things for your homework. So similar, but here we just want the username attached to a socket, so these two data structures will suffice. So when somebody connects, or registers rather, I'm going to update both of those maps with this new information I have. They're sending me their username when they register. The register message, they're just sending their username. So I have their username directly from that message, and then the socket ref from the on-data call. I'm always going to have a reference to the socket that just sent me this message. So I have the socket and the username. I'm just going to populate my databases with those key value pairs. And not strictly necessary, but a convenience for our app, for our user experience. As soon as they register, I'm going to send them the whole chat history, and we'll get into the details of how this method works. But I'm going to send them the entire chat history and the chat message event over that socket, so they can render the chat history and view the chat. But they can't view the chat until they give me a username. Once they give me a username, they can see the chat. Disconnect, just the opposite. I'm going to have a little bit of check here to make sure that the user is actually in my data structures. For those of you in the Tuesday 8 a.m. lab, this was my issue when the server was breaking a bit there. If I'm not checking this and somebody disconnects without being registered, I can have a server error and get all my data out of sync, and then the server eventually just starts crashing after that. So I'm going to check, make sure that socket is actually in my data structure. If it is, then I'm going to remove it from both my data structures and say that that user disconnected. Since the users don't have to send that register message, if they just connect and disconnect without ever registering, I thought I would get away with this in the lab because it's hard-coded in there to send the register message as soon as we connect with the two clients that I gave. But there are ways to break that without doing anything malicious, without really trying. It's easy for that to go wrong. So it's a good practice anyway to check, make sure that that contains it, and then delete it. Access the username and then delete those data structures. So I have two data structures that are keeping my messages. This will be important for the clicker homework and the lecture question today. This is probably the biggest thing, really the biggest thing that I'm testing in today's lecture question is when you get this register message, and can you update your data structures? So when somebody sends you a message that says, hey, I want to send this person a DM, with their username, find their socket, and then send a message over their socket. That's what I'm really asking you. That's what I really want you to see for today's lecture question. So that's the big takeaway for today. If you get nothing else, that's going to get you through the lecture question and help you to understand that part of the homework. Yep. When you change the username, it starts over.
You know how you have to go and you can buy shoppers and stuff. You change the username. The person using that clicker.
Oh,
Versus
right.
the entire number.
So for that, for the you'll build this part when you get to objective 3 of the homework, when you have the save and load features. So the way the clicker app works is when a user connects, when they send that register message, you'll create a new game actor for them, a new instance and add it to the actor system. And the first thing that game actor does is ask the database, hey, do you have this username in the database? And if the database says, yeah, that I have a save file for that username, it's going to send that save file as a JSON string back to the game. The game will parse it and populate all those values. So if you change your username, that user won't be in the database when you start a brand new game. But if you use, and usually you start a new game, if you just saved it, left it at test, because everybody was using that same name, and it just constantly got overwritten. But that's a side thing. But if you change that username, you would start over, and if you change it again, you would start the game over again. If you go back to your original, you'll get all that idle income and everything. Those are the features we want from that. For changing the username wouldn't be in the database, so the database would say you're starting a brand new game.
Okay, so you link the username with actor and the socket references.
Yep.
All three?
Yes, really, the server actually doesn't need to know the username though. So you can get away with just linking actor ref to the socket ref.
And then we can do the username.
And then you can always look it up. You never actually need the name. The only time you need the name is when you start the actor. And then after that, the game actor is the only aspect of the program that needs that username. You can still store it on the server, but you actually never, just going through the assignment, everything in the documentation, the server actually never needs to know that username, aside from when it starts the actor for the first time. That's the only time it actually needs it. So you can link all three. It won't hurt anything, but you can actually save a little bit of time, a little bit of programming by skipping the username completely. Okay. And then what happens when we get a chat message? So somebody sends me a message. This is only going to contain the message itself. So there's no JSON at this point in the program. When a user sends a message over the socket, they're just sending the message. But when we display the chat, we want that message affiliated with their username. So this is the first time where we're going to use those data structures that we were maintaining. So we're going to look, first do a quick check. Is this socket in my data structures at all? So did this person register and do they have an open connection? If they do, I'm going to ask my data structure, my socket to username. I have a socket, I need a username. I'm going to ask my data structure, hey, give me that username affiliated with this socket. Get that username. Just a print line to tell, so we can see what's happening on the server. Tell my database, add this message to the database. And then I'm going to broadcast the new chat history. This is a little inefficient, but for sake of example, I'm going to broadcast the new chat history to every single user. I could just broadcast the new message. I'd get away with that, but to keep the front ends a little simpler, I'm going to send the whole history out there. So broadcast to everybody the chat history, the new chat history with that new message. So that's most of the server. Let's take a look at a few things here. Do we even use chat message in this?
Question about getting the username there. So
Mm-hmm.
you have a specific value data with that username to socket and socket to username, right? So is there any way you can try to trick like it's up with the value of this key, get the key of this value?
At the value of this, you would have to write your own method. I mean, I think there is a built-in function somewhere, but you could write your own method to iterate through all the keys and values and say if this value equals what I'm looking for, return the key. But that operation, it's a little bit more coding, which isn't that big a deal, but it's also more inefficient. And there's nothing in a dictionary that prevents you from having multiple values at different keys. So you might end up getting the wrong key as well with that. So there's a few things that can go wrong with something like that, which is another reason why I like having the two maps. But you certainly can do that. You can write a method that iterates through all the values and then looks for that value and returns the key. So there's none, if that's how you want to set up your data structures, there's nothing stopping you. I want to stress that point that this is just how I felt like setting this one up. It's by no means the only answer, and it's by no means the best answer. This is just how I ended up doing it. So you could store these in a single one and then do what you're saying. Look up the key by value.
If the usernames are going to be unique,
They won't necessarily be unique, as long as you're careful with how you're set up. I can't even say that. If two users choose the same username, actually the way I'm doing it breaks as well, but you can have some ambiguities there. But I had that same issue here. When everybody was having the username test for the lab, that was constantly getting overwritten and behaving kind of weird. But yeah, there are definitely other ways to set up the data structures for this. All right, so let's look at the database. We called a few methods of the database. So let's take a look at what this is doing. This is probably the other big takeaway, at least just because next week's lab, you'll be using this. Some of you will be using this in 5 or so days. Is setting up a MySQL database, a MySQL server, starting a database, creating tables, inserting values into the database and whatnot. So we've seen a lot of this before, and yeah, on my laptop, my password is 1234567 Don't do what I do, but there's no actual sensitive data there, so I'm not too concerned. But maybe I should be. Don't hack me, bro. But anyway, I'm going to set up the MySQL connection. So I have MySQL running on my laptop, and I have this username and password, so I'm going to connect to that database. This is something you should all do before lab. Make sure you download and install MySQL for your operating system. Make sure you can run the sample code that I have in the repo, either this chat app or during the databases lecture, that sample code that I had for that. Make sure you can run that code and connect to your database properly. So actually, I didn't show that off in lecture. Since I'm in IntelliJ today, it's a good time to show that off. I had this code. We looked at this in the slides. It stores player locations and stuff for that. You can look over the details, or we can talk about it after class again. But if you have this database running object, and you should be able to run this. And get some meaningful output. If you can run this, with your database set up, replacing the password for your password, and if you want to keep it at root, that's fine. But replacing that password with whatever password you chose when you set up MySQL, and you can run it and get some meaningful output with no errors that say can't connect to the database, things like that. As long as everything works there, that means you do have MySQL up and running. If this example works, then look through the examples that I have in the repo. Make sure it all makes sense to you. Make sure you know how to execute a SQL statement and a SQL query so you can put data in the database and retrieve data from the database. Make sure you can do all of that before lab starts. If you say you set up your password wrong and run this, you're going to get some errors. If you've seen those errors, make sure you have those fixed before lab starts. So this, I wasn't able to connect to the database. I get a whole bunch of this stuff. Initialization error, not able to connect. Make sure you're not getting any errors like this. So our database here, the very first thing I'm doing is calling my setup table method, and if the table hasn't been set up a table named chat with 2 fields, username and message. So I just want to store all the chat history in this table. Have just the username and the text of their message in this table. If someone sends me a message with username and message, I'm going to prepare my statement with two values to be filled in. Always make sure you're using prepared statements. Never use string concatenation here. If you're doing something like this, you're wrong. Never do that. Because now somebody's going to choose as a username some SQL code, call that SQL injection, and they can really ruin your day, week, or month. And then use setString to replace by index each of these question marks. The indexing for this library does start at 1, so just keep that in mind during your lab. Starts at 1, I want to take the username, put that for the first question mark, and then the message as the second question mark. And then finally execute my statement. That's going to insert those values into my database, into that chat table. Whenever I want to retrieve the chat, I'm going to use select star from chat to get everything in the chat database. We're not getting very fancy with the SQL that we use in this class. Select star to get everything, and then we can, if there's values we don't need, we'll parse those out in Scala. Unless you want to learn some SQL, that's fine too. But if you just use select star and use the Scala that we know, that's fine. I'm going to execute this query to get a result set that I'm going to iterate over. I'm going to continuously get the next value as long as there is a next value. And then I'm going to get them by column names. So these column names that I used up here, username and message, those have to match down here. They're strings, so I'm going to get them as Scala strings, username and message. And then I'm going to create new chat messages, calling its constructor, which takes the username and the message, and pre-pending it to my linked list. And then finally returning all the messages as a list of chat messages. So chat message. Here's where we're using a little bit new syntax. So I'll talk about this a little bit here. It's actually, I'd argue that it's not even new syntax. It's just an extension of things that you know, but it's a neat application of things that you know. So I'll talk about it a little bit here. I have this chat message class. This is all familiar stuff. It has a constructor, 2 values. These can't change, but they can be accessed from outside the class, username and message. And an as.js value method to convert this value into a JSON object, which will be as a JSON value, but a JSON object by creating a map of string to value, JSONifying, is that a word? The username and message, and then to JSON on that. It's going to give me this message as a JSON value that I can then work with later. But the new thing is creating an object of type chat message in the same file as a class of type chat message. So I have a chat message object and class. Usually we've only seen one or the other, except for our servers, the servers that had an object containing a main method. We saw that a little bit, but I didn't really talk about it too much. But here I also want a from JSON method. Now I have a little bit of an issue here, is I would like a constructor of type chat message that just takes 1 string. But I already have a constructor that takes 2 strings, so I can't really do that. I could have some really hacky way to do it. Give message a default value of empty string, and then check if message equals empty string, parse the username as a JSON string. It'd get pretty gross, though. So what I can do is create a chat message object, create a method in here that actually creates and returns a chat message for me, and kind of use this as a second constructor to be able to create chat message objects. So if I get a JSON string with this from JSON, parse the JSON and create a new chat message and return it, I can actually, you know what, I never actually used that. I just wanted to show this off, but I never actually used it for this app. But anyway, I forgot about that. I'll show the usage though. And then some JSON string here. But if you do chat message the object, call that method, and you can create values of that type. Similar to this, if you create a message, what am I thinking? If you create a method named apply, that'll actually act as another constructor. That's how things like lists and map, how they get away with not using the keyword new. We're actually calling the apply method in the object of those data structures. So if I go here, it's actually in an abstract class. Right? Well, bad idea to go venturing into that. All right, so any other questions here? We covered everything on the server side at this point. Any questions about this? All right, so let's run this chat server. Oh, there is one more piece I didn't mention, of course. The chat history method. So here we're going to the database, calling that access full chat method. So we're getting every chat message as a list of chat messages, and now I need to convert this to a JSON string. I'm going to create an array with all the chat message objects inside that array. So for this, I'm going to use another new piece of syntax. When we get to level 4, we're going to talk about this kind of syntax a lot, so I kind of want to dabble into it, just get you exposed to it a few times here. Is I'm going to call the map method and give this a function, an anonymous function. I'm going to give it a function that's going to take a chat message, which is the type that this data structure contains, and I'm going to call some function on it, which is going to return something of some other type, in this case a JS value. And map is going to create a new data structure, in this case a new list containing all of the elements of the old list, but having this function applied to it. So take every value in messages, call this function on each value, and return a new data structure with the output of all of those function calls. So in one line, I can take all these chat messages, call that as JS value method on every single one, and get a new data structure with all the new values, instead of having to write a loop and then iterating over everything, populating a new data structure like we did all of 115 with that accumulator, gravity, I don't even know what the abstract term for that is. But when we did the accumulation in data structures, we can do that in one line now with this map and then give it a function to condense our code a little bit. Which, and by the way, using things like map and for each, these methods that take functions, this was something that I don't advertise it, but it is allowed in the calculator homework. So it is a way to get loop functionality inside the calculator homework, but you can't simulate any conditionals with it. So if somebody does use them, I let that fly. You can't really cheese the homework with these methods, but you can get loop functionality. But the loops don't really help you that much, as it turns out, for that specific homework. And finally, just return this all as a JSON string. Okay, so our server is fired up. We're listening on port 8080. Let's go to the web client first. So now we'll jump to the web client. This is pretty familiar from last time. I haven't got any fancier with these GUIs that I'm showing you. They're fairly straightforward, simple, basic, and boring. But it's not an HTML course, so I'm not too concerned. I'm going to grab my JavaScript, grab the library. I'm going to have an enter username in a div. Put this in a div just because I want it to disappear when somebody enters their username. And I would have this as 2 separate HTML files, but I haven't set up a server to serve the files and have get and post requests handled in any special way. It's front end only, so I just did it this way. And then a chat with an empty div to display all the chat. In JavaScript, nothing too crazy here. Whenever I receive the chat history, I'm going to call an update method with that JSON string that I get. And this is, like for demo 2, you wrote an update method that takes in a JSON string. This is what we're going to end up doing in demo 3. That update method you wrote, we're going to use that, and then we're going to add in the sockets. Whenever you receive that message over the socket from the server containing the latest game state, you're going to call your update method and say, hey, update the GUI with this brand new information that I just got from the server. And you'll continuously call that update method whenever you get more information from the server. And we'll do this, say, 10 times a second. We could try to go up to 30 times a second, depending on network lag and everything, and get a smooth looking animation based on your code from demo 2. So demo 2, you just took one JSON string and displayed it on the screen. But if we're calling your update method 10 times a second, you're actually going to get some animation. That whole GUI is going to come to life when we're calling it that many times. And we're getting those messages from the server 10 times a second, or however often we end up getting those messages. So you have an update message, an update from demo 2. This is certainly way simpler than what you did for demo 2, but I'm just taking this JSON string, parsing it, and displaying all the chat in that div, in that chat history div. But I'm calling, whenever I get the chat history from the server, calling that update method with what I get from the server. Register, when I click that register button, grab the username, send the register message, and then I want to, I ended up doing it that way. Just blank out that whole inner HTML div, just destroy all that HTML. It works. Not the prettiest thing, but it works. And then finally send message. Whenever you click the send button, I'm going to make sure you're registered first with this, just a flag that I have. Again, not the prettiest stuff, but it works. And then grab whatever message you have, blank out the message box, and then send that to the server, send that new chat message to the server. So let's register. I'm just going to chat with myself. And we get those instant updates. As soon as I send a message on one client, it's going to immediately appear on the other side. Oops. And we can chat. I'm not going to chat with myself too long. All right, and to round this out, let's look at the last piece we have here. Oh, and we can see all my server logs, just my print statements that I'm printing to the screen. Let's look at the last piece here is we want a GUI as well. Let me do this a little backwards from what I just did. Let's run this first. That one's going to be hard to see. Submit my username. I can see all the chat. We send the chat history once that message comes. I can send messages. Across all three. So we have a chat app that works. It's all using network technology, so this is on the internet, and everyone on the planet's using it. It's going to work just the same. We have these live updates as soon as any user does anything, which is what we want from our chat app. We don't want that lag. We don't want to wait up to a second when somebody sends a message. All right, so how did we get that GUI working? There are a few things that we saw there that, again, you probably did something more sophisticated for your lab demo 2, but let's take a look at what we did there, and maybe some that can help you revise your lab demo 2 code. I don't know. You probably already figured these ones out from reading documentation. But I'm going to connect to the socket. I'm just going to, wait, I don't do that anymore. Oops. I had it hard-coded during testing, but don't need that anymore. And I'm going to create my elements. So these are the elements that we see in the chat. I'm going to use a text field to enter values, a button, and then a text area to be able to display. A text field only gives me one line. A text area will give me however many lines and columns that I want, lines and rows. I'm going to set the size based on the rows and column count, and then set my window height and width to make sure that I can fit all those elements on the screen, or else that window is going to be pretty small. It's going to be too small. So I have these three elements, and I'm going to put them in a list and just kind of shelve those for now. So I built these elements, I put them in a list. They can be added to the GUI, but I'm just going to hold off on that for now. I'm not going to just throw them right onto my GUI. I'm going to create a content box, which is going to go, oops, where am I? Content box, which is going to go on my GUI. That's going to go on the GUI, but I'm going to save a reference to that vertical box so I can change it later, so I can modify the elements that are being displayed. So I have these chat elements, the content box, and I'm going to build the part of my GUI that's going to be the register page. So when we first went there, we had a text box and a button for registration, for submitting your username. And when I get this action, and I'm using that syntax that we talked about last time, I'm just giving it a function with the proper types, and then it's going to do the extension, the overriding, and all that for me. So I'm giving it something that takes an action event, and it's going to know, oh yeah, this is going to be an event listener of type action event. So it takes an event, sends that register. This isn't strictly necessary, but I'm used to doing that each time. And then I'm going to go to that content box, and after somebody registers, I'm going to go to that content box and replace the content of it with those chat elements that we had before. Oops, I skipped this part here. The elements for the username input, those two things, I'm going to put that in a separate list, and then the content box is going to be initialized to those registration elements, to those elements, and then when that register button is clicked, I'm going to go to that content box and replace it with all of my chat elements. So it looks like the whole GUI is changing, and yeah, it is. But I'm doing that by updating the content of that VBox. And we can do this in other ways. These containers can be nested in any way we want to mix and match them. So if we get any way we want to change those elements, we can swap those out and change the whole view as we go. So for later on in your project, you'll need to be switching between the overworld and the GUI. You just switch all the content of that GUI, the whole container of the GUI, you can get that switch. And finally, the listening. So whenever we get a message, where are we? Message of type chat history. Oh yeah, click the buttons, omit the chat message. Not as interesting. But chat history, whenever we get a message of that type, we're going to go up to our emitter listener, run this code, get the message, parse it. I'm going to blank out the chat, just destroy everything in the chat, and then loop through all of the values in the chat history and add them all into that chat box. And this gives us a nice feature. The last thing I need to show here, let me just mesh for a while. I shouldn't have made it so big. Oh, two more things I have to show, actually. There we go. This text area gives us a nice scroll bar. So once we fill up the text box, we can still scroll through all the chat history. And the browsers, of course, do that just automatically. One more thing I want to show. Let me close, stop. Chat server stop. So everything's shut down. My whole program has ended. All the memory's free, the heap's gone, the stack's gone, any stack frames, everything's gone. I'm going to run my server. With 6% left, we can do this. I run my server. Hopefully that was long enough to free up the socket because I didn't close it. I didn't stop it properly. We'll see in a second. All right. And as a proof of concept, let me fire up my GUI again. I shouldn't have went for it. Oh my goodness. Oh, I didn't register. Yeah, obviously. I was panicking. There we go. All the chat history is still there. So the whole program is gone, all the memory was wiped. But since I'm using the database, I'm pulling the information back from the database. It was stored, it persisted in MySQL, in my database. So all that information is still there. That part you'll have to do in lab as well. You have to restart your program, shut everything down, and then fire it back up, and make sure that everything that's stored in your database it did persist, did work properly, and pull your data back up after that restart. All right, with that, any other questions? All right. Oh, one more thing I forgot to mention. I forgot to add this to the slide. I'm surprised I did. The lecture questions due Sunday night, and it's worth 20 points. So you have some time to work on that thing. With that, have a good weekend.